walk you through some of the calculations for the measurement and uncertainty lab. Part A and B, you're just collecting your data. You don't really have to analyze anything. So part A, you're going to have these different water baths, and you're going to measure the temperature for that. And part B, you're just going to weigh out all the different things in your lab kit and get used to using your balance. But in part C, you're going to start playing with the syringe, and you're going to have to measure some volumes, and there's some calculations involved here. So I thought I'd walk you through some of these. So this was everything in red. That's my collected data. So I measured my water temperature. I got 20.5. That was my room temperature, and you need that to look up the density in the table. So that's why we're collecting that temperature data again. And then the way the directions walk you through this lab, they say first, fill up the syringe almost completely full. So I went to 19 mils. You might go to 20, you might go to 17. You might have different data. That's okay. Then it tells you to go down to 7 mils. So you're reading the syringe. You're starting off with whatever you're reading. Your initial point was go down to 7. You can do that pretty quickly, and then slow it down for the last 3 mils. So once you're at 7, go 3 more mils and do it dropwise until you end up with 4. So my initial reading was 19 for trial 1, and my final reading was 4. And then for my other data here, then in step 2, they say start at 16 and go down to 7, and then goes dropwise down to 4. And then trial 3, start at 12, go down to 7, and then dropwise until you're at 4 mils. So that's where I got my initial and my final volumes from. You are putting all of it into the same graduated cylinder. So you get your 50 mil graduated cylinder, and so then you're reading those at each point. So my reading of I put 15. Sorry, I started at 19, go down to 4. My syringe, I could read the syringe volume changes, and then I'm also reading the graduated cylinder volume. So that was 15 there. And then I keep that 15 mils in there for trial 2, and then I empty from 16 to 4 into the graduated cylinder, and then I read the volume. And that's going to be, 27 and then 35. So the first set of calculations that you really have to do here, just, set of subtractions. So you're going to do 19, if I had 19 minus 4, right, that should give you 15. So here I'm going to type 15. And then in trial 2, I had 16 minus 4. That gets you 12. Put 12 here. And then 12 minus 4, that's going to give me 8. Oops, 8. All right, so I have my new volumes there. I measured that. So then after I did my final step, right, and I read my graduated cylinder was 35 mils. I know I have about 35 mils in there. Then I put the graduated cylinder on the balance. The very first step after you measured the temperature, you measured the graduated cylinder when it was empty. So that's your empty weight, which you also got in part B, I think. And then you have it with when it's full of water, so you just have to subtract there 57.15, subtract out 22.42, and you end up with 34.73 grams there. So that's my mass of my water, 34.73, which I just got from subtracting. This is the mass of all the water that I added plus the graduated cylinder. Subtract out the mass of the graduated cylinder when it's empty. And now to figure out what the density is, I'm going to look this up in table 1. So table 1, I'll show you table 1. Okay, so this is at the very end of the lab procedure. You have this big table, it's kind of complicated. You're going to look for whatever temperature you have there. So mine was 20.5. So I'm going to do 20, go to 20 degrees Celsius, and then this is going to tell me what, decimal place. So I read over at 20.5, not 25, right? 25 would be down here if it was 25.0, a little bit different. I have 20.5. Make sure you read one decimal place after when you're reading the graduated, when you're reading your thermometer, get one decimal place on there. So I've got 20.5, so 0.9981. That's the density of water at that. Now, if you were to round all of these up to, 1 sig fig, you got 1. It's 1 gram per milliliter. This is just with a little bit extra sig figs here. So 0.9981, that's the density that I have here. So 0.9981. Now, are you going to have the same density? It depends. If your temperature is 20.5, you'll have the exact same density that I did. If you have a different temperature, you're going to have a different value. That's okay. That's the whole point of this. You're going to look up that density in the table. All right. Now, to figure out, the total volume of water that was delivered from the syringe, I am just going to add up, 15 plus 12 plus 8. When I add that all up, right, this is, 15 plus 12 plus 8, that gives me 35. 35.0, they all have one decimal point on there, which was exactly what I got when I read the graduated cylinder. Now, you might not get it to be exact. It might be off by a little bit. When you're adding your drops, you may have misread the syringe a little bit, or you could misread the graduated cylinder. You could add an extra drop by accident. There's a lot of things. These don't have to add up exactly. Mine happened to add up exactly, which was great, but it doesn't. They don't have to be. Don't worry if you're off by a little bit. That's what we're going to do. We'll calculate. We'll calculate some percent error based on our volume. So now what we want to do is I have the density and I have the mass. I'm going to calculate a volume. This is our theoretical value. This is what we actually measured. This is going to be our theoretical value based on the mass and the density. So remember that density is equal to mass over volume. If I solve that equation for volume, I get volume is equal to mass over density. Mass divided by density. Okay, so that's what I'm going to do here. And I'm going to actually write this out. So my volume is equal to mass over density. So I have my density and my mass here. So mass there we go. 34.73 divided by the density 0.9981, and that gives me 34.79.796. I'm going to go I'm going to round that up, 34.80 grams. All right, so that's my, sorry, not grams, milliliters. I'm calculating my volume. So I got 34.80 mils. Right, and that's going to be the same for this one too, 34.80, because that's the mass and the density. That didn't change. Now to get the percent error, I'm going to do right, 35. That's my measured value. Theoretically, it should be 34.8 based on the density and mass that I found. So I'm going to do 35 minus 34.8 divided by 34.80 times 100, and you're going to take the absolute value of that. In this case, it's going to be positive anyway, but if you had this number bigger and you end up with a negative number, just take the absolute value, just make that positive, and you'll be fine. So I ended up with a 0.57%. That's going to be both. Now, if you had a different number here, then you're going to want to do that twice. 0.57%, 0.57%. Great, so those are my calculated percents. Great, so that's part C. Part D, similar, but now we're gonna have just give us more room here, so we're all on one page, and I'll just work out stuff under here. So now instead of using the syringe, we looked at the disposable pipette. So again, my temperature was the same. I used the same water, and what we were doing was we had our 10 mil graduated cylinder, and you're adding 2 mils. All right, so I'm counting how many drops of water does it take to get to 2 mils. So I'm constantly looking at the volume of the graduated cylinder. It took me 46 drops in this case, and then I kept the water in the graduated cylinder, and then I added two more mils by drops, counting the drops, and it took me 45 drops to get to 4 mils. I did the same thing to get up to 6 mils. So I keep adding in 2 mil increments. I would lose count, I think, if I had to start at 0 and add 6 mils and try to count how many drops. So we kind of split it up into, count this. Plus you're gonna have to keep refilling the pipette as you go. So to find the total number of drops, you're just going to add up the 46 plus 45 plus 45, and that should equal 136. So that's where I got 136 drops. Great. I measured my graduated cylinder when it was empty, and then I measured it after I added these 136 drops in there. And so this is what when I put that on the balance, I got that. So to figure out the mass of the water, I could just take the difference between those two numbers. So I'm going to do the 15.55 minus 9.61, and I get 5.94 grams, right? So that's the mass of my of the water that I had. The density in water, since I used the same temperature, my density is going to be the same as it was before. So if you go back over to this table, remember I had 20.5, so I went to 20, and then over here at 0.5, so I got 0.9981. That should be the same as part 1, so 0.9981 9981 grams per milliliter. Now to calculate the calculated volume, I'm going to do the same thing that I did last time. Density is mass over volume, so volume is mass over density. So volume is mass divided by density. So I'm going to do that here. I'm going to do the mass, 5.94 divided by the density, divided by 0.9981. And when I work that out, my new volume that I'm calculating is 5.95 milliliters. Okay. Now, drops per mil, I'm just going to take my 136 drops and divide it by the milliliters, 5.95. So take the total drops, 136 divided by the volume, 5.95 mils, and I got like 22.9 drops per mil, or I'm going to just round up the whole number of drops, so about 23 drops per mil. And if you want to reverse that, you want to figure out what's the volume per drop, you do 5.95, so whatever your volume is divided by the drops. So I had 136 drops. When I work that out, I end up with like 0.04 mils. So you can insert the pictures there wherever the instructions prompt you to take a picture. And then if you want to work out your calculations in here, you can show the different steps that we were just working on.